All right, so for 31, we got Tarzan swinging on a 30-meter long vine. Hey, and notice here, notice the mass of Tarzan is what? Read the question. What do you notice? It's not given. Do they mention the mass of Tarzan? No. So guys, when you are doing a problem, everybody listen to me. When you are doing a problem and the mass of the object is not mentioned, what does that mean? It doesn't matter. It's going to drop out. M will cancel. As we set the problem up, the mass of Tarzan's going to, it doesn't matter if he's 10 kilograms or 100 kilograms. The answer will be the same. Okay, so Tarzan starts here from rest. So V initial is 0. And he swings down, and the rope is 30 meters long, and it makes an angle of 37 degrees with the vertical before he starts the swing. So what we're looking for is Tarzan's velocity as he passes through the lowest point. What is the final velocity at the lowest point? Okay, so this is going to be conservation of energy. So we have to set our 0 point. The best place to put the 0 point is at the lowest point in the problem. So where's Tarzan's lowest point? His lowest point is at the lowest point in the swing. So it's right there. This red line is H equals 0. Okay? So let's go through our energies. So the idea with this chapter is that mechanical energy initial plus or minus any work non-conservative is going to equal mechanical energy final. Now, does this problem have any non-conservative force doing work? What's the only force that does work as Tarzan swings? Gravity. Hey man, what about tension? Isn't the rope exerting a force on Tarzan? Tension in the rope? Yeah. But how much work is being done by the tension? 0. Who can tell me why? You guys are a very quiet class, but I know somebody knows. Why is the rope not doing any work? And I'll give you a little hint here. Why is the tension force not doing any work?
It's perpendicular.
It's perpendicular to his motion at all points. No matter where you look at Tarzan, the tension in the rope is perpendicular to the way he's moving. So the tension in the rope does not do any work. The only force doing work here is what? Gravity. Okay, so long story short, what can we do to this work non-conservative here? Cross it out. We don't have any. This problem is purely conservative. Okay, how many types of mechanical energy are there? Quiet class. 3. I know you guys know. I know you know. You know, and I know that you know. Okay, so the 3 mechanicals added up are going to equal the 3 mechanicals added up final. So initial equals final. So gravity final, and then squeeze in here spring final. Does this problem have any springs? Nope. Other problems will. This problem does not. So what can we do to the spring energies? Spring energies initial, spring energy final, cross it out. Okay, kinetic initial. Does Tarzan start with kinetic? Up here. No, what do they tell us right here? In part A, if he starts from rest. What's his initial kinetic? 0, cross it out. How about potential of gravity initial? Does Tarzan start with potential of gravity? Yeah. How do we know? He is above the 0 point, so he has an H. MGH, he has an H. Okay, Tarzan swings down. Does he end with kinetic at the bottom? Yeah, how do we know? He's moving. Does he have potential of gravity? Nope, because where is he down here? Where is he right there? on the 0 point. Okay, so gravity final, that's 0. So here's what we're left with. Potential of gravity initial is equal to kinetic final, right? He starts up here. Up here, he starts with potential of gravity. That potential of gravity gets converted to kinetic. 100%, because there's no non-conservative force.
Wait, so why did we take out the gravity one on final?
Oh, because this final one here, potential of gravity final, it's 0 because right here where I'm circling, this is his final. And notice that he's on the 0 point. So potential of gravity equals mgh. When you're on the 0 point, your h is 0. So if that's 0, then you have no potential of gravity. When you're on the 0 point, you have no potential of gravity. Okay? So, what's the equation for potential of gravity? mgh. What's the equation for kinetic? 1/2 mv squared. What did I tell you about the masses? They're going to cancel. See right here? M cancels like that. So we get V is equal to square root 2gh. Now, we are to the tricky point in the problem, which is finding h. You know, if you're going to find this problem difficult, that's why. So how do you find your h? Well, look, let's make some triangles here. Do, like this. I'm going to clean this up a little bit. Erase these guys. Okay, so h is his vertical height above the 0 point. This is the h right here. Now look, if you make a triangle like this, go do like that, up like this, that's a 90 right there. What's this distance right here going to be? You can use some trig. Cosine 37 times the hypotenuse. So that distance right there is equal to 23.96 meters. Now, guys, what is the distance from this dot to where Tarzan is, or between those two dots? What is the total distance from up here to down there? This total distance is what? It's the length of the rope, right? The rope just goes and comes down like that, right? So how do we find h? H is going to be the total, which is 30 meters, minus this part, right, which is 23.96. So h is 6.04 meters. So we plug that in down here. So that's going to be 2 times 9.8 times 6.04. And this gives us a velocity at the lowest point of 10.9. Okay? Now real quick, part B. If Tarzan pushes off with a speed of 4 meters per second, how does this change the problem? If he pushes off with a speed of 4 meters per second, go back up to here. What would not be 0 here? Kinetic initial. If he pushes off with an initial velocity, he's going to start with some kinetic energy. So here's how you would do that. So for part B, you're going to go potential of gravity initial plus kinetic initial equals kinetic final. Okay, then you plug in mgh 1/2 mv squared 1/2 mv squared, where this is v final, this is v initial. Hey, if there's two velocities, guys, you got to specify. See what I did here? I put v final, v initial. What happens to all the m's? The m's drop out. So now you can solve for v final. So that's going to be equal to square root of 2GH plus V initial squared. So that's going to be 2 times 9.8. H is still 6.04 plus V initial is given as 4. So you plug into that. So I'm getting 11.6 for B.